Good afternoon, everyone. My name is Vineeth. Hope you guys had a good lunch. I'm an application security engineer working at Amazon Web Services in New York City. I mostly work on AWS services that are part of the Hadoop big data ecosystem, like EMR, Elastic MapReduce, Athena, Lake Formation, and Glue. Before this, I worked as a pentest engineer and threat hunter for Nordstrom back in the West Coast. I was also an adjunct instructor for the University of Nevada for some cybersecurity courses. Outside of work, I really enjoy skiing, but haven't found any good snow on the East Coast. It's just all ice, unfortunately. Um, so yeah, in the past couple years at AWS, I've threat modeled at least 130 to 150 features for Tier 1 AWS services. And my goal at the end of this presentation is to convince each and every one of you that threat modeling can be done effectively at scale, and it's probably the most effective proactive security measure that you can implement in your software development lifecycle. Cool. So let's start by acknowledging the elephant in the room, right? Everyone's moving to a microservice-based architecture, and the complexity is increasing exponentially, right? With so many of us moving to this new microservice-based architecture, we have a growing web of interactions that gets really hard to track down over time. Having this really large complex architecture means our threat surface and our security posture are also harder to secure, right? We have a lot of moving parts, there's opportunities for things to go wrong, and each new interaction can lead to, could possibly lead to a malicious actor gaining access to our system. So think of this as like a really big city. With each new building, you have to build a new road, and with more streets, the more surface you have to cover for your risks. It is crucial to understand and mitigate these risks because a single bad microservice can lead to cascading issues across the entire system. I know we've recently started moving to zero trust architectures, but a lot of us, where companies are much older, we haven't moved to this zero trust system yet. And that image there is actually Amazon.com, just Amazon.com back in 2008. Each node is a microservice, and each edge is an interaction between those microservices. You can only imagine how much more it's grown since then. And so, okay, so let's look at how do these security issues or vulnerabilities get introduced in the first place. So this is our SDLC, right? We have different phases where we get our requirements, we design, we build, test, deploy, and we do this quite often. And we can introduce these security issues at many points, but mostly it's during code and configs, and it happens a lot of times in the design and build phase, because sometimes you might design things that are inherently vulnerable, or sometimes the code itself is vulnerable. And so we also have a lot of different opportunities to find out where our issues are. So we can identify our risks, like working backwards, all the way from live production. So our bug bounties, security researchers, hackers, white hat, black hat, they can all help us identify risks in our system. But it's always better to do so before it hits customers. So we can find issues in our deploy stage. We can find issues in our test phase. This is the most popular place where and also the place where we invest the most amount of money for finding issues. This is where the pen testing happens. There's an entire industry built on this phase. This is where our dynamic analysis happens and all of the good stuff there. And in our build phase, we can do code reviews and static code analysis. But I specifically am interested in the design phase, because irrespective of all of the other places where you could find issues, they are mostly bolted on. They're not security issues that we can identify with the system itself, right? Because when we build physical infrastructure, we design with security in mind. But for software, for some reason, we try to bolt on security at the end minute, and it gets really expensive really fast, right? Fixing an architectural issue in production gets really expensive, because not only do you have to redesign it, but you have to build it again, test, deploy, and it gets, and so that's where the shift left mantra has been, getting really popular these days. And so threat modeling is, I would say, the first phase where we can actually find security bugs, and I think is the the easiest place to find them because you don't have to do a lot of code review. You don't have to go deep into it. All you need to do is have a good understanding of your system. And so, again, why use a threat model, right? So the combination of early insights that can be derived puts you in the best position to build and protect your product or service securely at the lowest cost and effort and time. So the cost, as I said, like increases as you move across the SDLC. And so threat modeling is the cheapest way to add security to your pipeline. Cool. So when do you threat model? So I like to say earlier the better, the more often the better, and it's never too late. A good time to trigger a new threat model is when you introduce a change or a new feature to a system. Threat modeling should be done in feature sprints because any mitigations or things that you discover can always be added to your backlog and then prioritized at a later date and implemented. Another good time to do threat modeling is when previous assumptions that you've held true no longer hold true, either because you've added a new feature, a new researcher figured out a way to do something really bad, or the threat model becomes invalidated by a change in the development environment. A lot of times, for example, Log4j, right? That issue caused a lot of us to rethink how our systems are built. And so a threat model can be triggered at any point. But even if your system is in production, right? There's no harm in threat modeling a system in production. In fact, I would urge everyone to do so because you can always miss things when you did, and it's always good to threat model. And so, yeah, so again, do it as early as possible, as often as possible, and it's never too late to threat model. Cool. And so let's just really quickly talk about the basics of threat modeling. These are Adam's 4-question framework. Most of you are probably familiar with this. How do you, you have 4 big questions. What are you working on? What can go wrong? What are we going to do about it? And did we do a good job, right? The first question is, what are we working on? The intent of this question is to help you set a baseline understanding of the system that you're building and the details that are relevant to security. Creating a threat model or diagram is the most popular way people do this. The second question is, what can go wrong? The intent here is to analyze the output from what are we working on and then come up with a list of issues or risks or threats that can affect your system. And then the next step is, what are we going to do about it? Here, your goal is to come up with response strategies to your different risks and threats that you've discussed in the previous step. And then, did we do a good job is a question that's designed to make you contemplate on the process, see how you can improve, because there's always some room for improvement. And the result of the threat modeling process is a creation of a living and dynamic threat model that can be updated over time. There's a lot of tools that exist, and there's a different bunch of methodologies that also exist. Some of you must be familiar with a few of them. Some of you, I know, hate a few of them as well. And there's also a bunch of open source tools as well. But all of them boil down to the same few steps like we discussed. First is to have a complete design document and an architecture diagram. These serve as a blueprint, providing a comprehensive overview of the system components. Next, which is the bulk of the threat modeling, is to list out the threats and mitigations. We systematically brainstorm potential threats ranging from common vulnerabilities all the way to really complex, sophisticated attack scenarios. For each threat identified, we develop a corresponding risk response strategy, either to neutralize, minimize, reduce, or transfer the risk. Together, these practices form the backbone of a threat modeling process, and they lay the groundwork for all future security testing as part of your SDLC. While traditional threat modeling approaches have their merits, they also come with a set of challenges. I'm sure most of you have faced this before. It takes an immense amount of time to get 10 people from different verticals into one room and actually threat model, right? It's also very rigid. Following stride or pasta gets really rigid. It's not very flexible, and it really slows down the development process. Security is already seen as a bottleneck, and we don't want to add to the the notion that we are slowing people down. Another challenge is shortage of security engineers. There's a huge demand for security engineers, and it's really hard to find them. So being able to scale this without having as many security engineers is also really important. And lastly, traditional threat modeling suffers from lack of standardization. Two people can threat model the same exact application and come up with totally different threats. And this variability can lead to inconsistencies and inefficiencies in a threat model. It makes it hard to agree upon one model and makes it really challenging for developers to decide what to do. But again, despite these challenges, there's always a place for doing traditional threat modeling. If you're only launching 4 or 5 things in a year, or you have a really small set of things you're launching, doing the entire slow process, works. With just a raise of hands, how many of you here threat model at work or have done threat modeling before? Cool. How many of you do it for every single product, feature, or system you guys release? None, right? Because it just doesn't work at scale. It's super hard to do it, and I've only seen a few places that have done this, relatively successfully. So let's just take my approach is okay, we're in 2024. We can't be wasting time looking at XSS, CSRF, and these low-level threats. Delegate them to the machine, and let's focus on the higher level, bigger picture, business logic issues, right? Our goal here is twofold. One is to prevent developer fatigue. That happens quite often. Security tells development, hey, here's 200 things you need to do, and here's 1,000 findings you have, go fix them. At some point, they're just going to give up and not going to look at them. And so, and also we should avoid making security a bottleneck, like I discussed before. So, okay, now we've done away with the easy stuff, right? We've automated some things that we can. So who's heard of the OWASP ASVS? Who's actually implemented the entire OWASP ASVS? Okay, right. So one step further, after getting rid of the low-level stuff, is to build upon the standards the security community has already come up with, right? An example, here's a few examples from the ASVS from version 4. I just picked out a few random ones. So the first one is verify that cookie-based session tokens have secure attribute set. So here if you think about this, although this is a requirement, it is basically a shortcut to a threat we already had. So there's a threat implied in the statement, right? The threat here would be a bad actor is able to view the contents of a cookie in plain text. So the OWASP ASVS does a good job in providing requirements and to make your system secure, but it abstracts the threat layer, right? Imagine giving a 15-page document to your developers and be like, hey, implement everything. I don't know which ones apply, but go ahead and implement it, right? They're not going to listen. They're probably going to throw it in the bin as soon as you leave the room. So we can templatize this, but this generic one-size-fits-all just doesn't work. And so what we can do is we can take this one step further, and we can decompose the application into multiple reusable components, and then set model or use templates for them specifically. So just like a modular house that's built off-site, we can bring parts, because no one's creating brand new frameworks every day, right? You're using the same 10 tools that a company uses over and over again in different places. So the goal here is to create reusable components and predefined threads that developers can leverage to streamline the threat modeling process. By adopting this modular approach, developers can inherit predefined threats and don't have to spend a lot of time thinking about new ones and new mitigations and so on. This also reduces the time it takes to develop and reduces the bottleneck. It also gives developers the option to pick and choose what they want, because giving them or prescribing them, hey, you have to do this, is not going to work. And sometimes the business needs come over security needs, right? So letting them pick and choose what they want, which components they want, gives them the flexibility to develop at a faster pace. But, okay, we'll come back to issues with this. Here's a really simple diagram. So giving some context, right? Let's say you guys all work for a transit company, and you're the sole security engineer for the company. You're working on a new website because it's 2024 and the transit company finally wants a new website. your developers come up with this really high-level design for the website. Can any of you just yell out a few threats that could potentially affect the system? Idor, good one. Anyone else? Yeah, that's just a random profile number. DDoS? Injection, because you have user input. Anything else? Yep. All right, you guys are all right, right? So these are all potential places where, a bad actor could, impact our system. So we have, like you said, IDOR, you have user input, you have file upload, and then on the component side, you have a database, you have a web service, you have an API gateway, and so I would say 70% of the applications are the same REST API like web services, right? It's just API after API, and so we can, like I said in the previous slide, you can build threat model for components specific to components, and then reuse them across various applications, right? So we can ask our developers, hey, what compute service are you using? What framework are you using? What API endpoint service are you using? And they can pick and choose what they want. We can take the ASVS or some derivation of that, and then create our own component-specific threat models. And then once the developers pick and choose what they want from the initial questionnaire, they can inherit all of these threats and mitigations, right? This is similar to object-oriented programming. We can overload, polymorphism, all of the good stuff. So this is like step one and the easiest way to get your company or your organization to threat model at scale. Give the developers the options they want, build these predefined scripts, and then they're happy, you're happy, and at least you're getting a good 80% of your threats covered. We can take this one step further and make a threat model machine readable. A lot of times when people do threat modeling, it's usually on PDFs, docs, and how many of you have finished deploying something, 1 year later went back and read the design documents? Anyone? No, right? It's just not going to happen just because it's so much work and we never go back to see old documents. Just like old logs, we never see them, right? So unless something really went wrong. So using a threat model like either in JSON, YAML, or any machine-readable format that can be iterated over time and not using a static document can really help you scale threat modeling across your entire company. There's an added benefit of doing this. The machine-readable document also facilitates automation, integration with other development tools, and can also act as an asset inventory of all the components in your system. So if you have a threat model for various components and you know how many times this component was used, you can create a really detailed asset inventory of everything that's in your environment. Another thing that you can do is have a threat catalog of all threats that impact your entire organization. So leadership can have a high-level view of, hey, these are the components we have, and these are the largest threat surface that we have. And so it gives them a way to prioritize, different things like mitigations, hiring, so on. And so, and again, like I said, you can take a machine-readable format and then deploy it as part of your CI/CD pipeline, and you can integrate it with other tools as well. And with LLM and AI coming, I don't want to say this, but everyone's saying it, so we can dump this into one of the LLMs and ask it to see what it can get. I've not tried it because I'm not allowed to. If any of you are allowed to do it, feel free to go ahead. So this is just an example of a threat model in JSON format. I don't know how much you guys can see, but it's just basically a bunch of threats and linked mitigations. So we can stop here and be done, right? You've put in 20% of the effort. You've just taken the pre-existing standards, templatize them for various systems, and let your developers pick it. We can stop here, completely be done. And you cover 80% of your threat security outcomes, right? But a lot of us, we need the 100% because you're probably in an industry where you can't afford to lose something, right? This is where it becomes a little more tricky, right? The rest, 80% of your effort will just go in 20% of your security outcomes. But if you guys have seen the recent news, a lot of the recent incidents have been business logic level. Not often do we see, hey, XSS on Google's front page, right? It's just much more rarer for those issues to come out. And a lot of the issues now are mostly business logic focused. So, and one issue with the previous method is components are feature agnostic. You can have the same API gateway being used across 20 different components, but used in different ways. Same thing for your databases, same thing for your web service or your compute environment. So what we can do here is we can take our components and actually threat model the features the components are built on, right? So we can, as we add more features and more components that were underneath that, things that haven't been touched in years, you could possibly introduce new data flow paths or new vulnerabilities that you didn't intend to. Or a previous mitigation for a threat that you thought was fixed can now be exploited. So threat modeling features is the rest 80% of the effort that you'll be putting in. And this is also the hardest part because each feature is different, and this is what takes most of your time. And adding new features, again, can fundamentally change the structure of your application, even if you haven't changed a single component. And I have a few examples of, and I'll show you how this can impact features. So in our previous example, you guys were all, again, working for a transit company. Now, after a few months, your product team comes back and says, hey, our users want to check the trip history. Can any of you yell out a few threats that could impact this new trip history feature that we are implementing? Anyone? SQL injection, nice. Anything else? Yep, brute force. Yep, encrypting address. Because now you have credit card information, right? You have a beast called PCI DSS compliance sitting on your head right now. So just a small new feature where you haven't introduced any new component, right, can introduce a lot more, requirements for you. So again, so you guys will write brute force, injection, and so on. Let me quickly switch to. You guys see the screen, or should I zoom in a little? Give me 1 second. Okay. Is it better now? Okay. Cool. So I've just taken our existing system and I've just drawn it out in a data flow diagram. So you have an actor, you have a login page, register page, you have the account details page, and a database that just has a bunch of information about the account details, right? This is what we had until the trip history feature was created. So let's maybe take a minute to just add. Give me 1 second, I can't see much from here. Okay, let's add a new database. That's your trip history database, right? So we have a new database, that's your trip history database. And then your actor can now either talk. So actually, before that, we've had a trip history database, and it was we had to be authenticated to see the trip history of our users. So the way they would come is via the account details page, so they can come and then see the trip history from here, right? So this is just a new flow that we added to our system. So with this flow, we can add hey, we can see if this system is using any authentication. So let's go and add this to our threat model. So we have database authentication. Let's assume it's a MySQL DB and has some simple authentication. It does implement some secrets, and let's see, it uses, is that CSV? Yeah, it uses CSV. So here's basically what we added to our system. Now, a few months later, your product team comes back and says, hey, our customers really like this feature, but they want to see the trip history without logging in, right? So it looks, give me 1 second. Okay, it looks something like, okay. It looks something like this. You don't have to log in. You can check your trip history with just your credit card and expiration date. Do you guys see any big issue with this? Exactly, right? how many of you have had like fraudulent transactions happen on a credit card? The number of times credit card information is leaked on like any of these dark web net sites is like really high, right? So we just, or just a picture of a credit card, you can get the trip history of a person, and especially if they use this transit system. So going back to our website, our threat model here, as you can see, we've added a new interaction from the user directly to the trip history without any login, right? So you're not going either the login route or the account registration route. So this is basically, again, no new components, just a new interaction, and we just removed the authentication feature. If you think this was so obvious, I'm sorry to say, but the New York City Metro did that. They implemented this in 2019, and it's caused a lot of issues because you can stalk someone because you can see the time at which they took the subway, which station, when. You can easily get the information or the habits of a user, right? Stalking and other issues start coming up. So again, to us it seems so simple because we drew it out. We had base level of threats and we discussed it, but an entire agency implemented this in 2019 and discovered the issue in 2022. So again, threat modeling is not as common as you think. We've all heard about it, but not enough people do it. So yeah, and again, right now they've disabled the entire feature, so none of us can see our trip history. And so let's go back to the threat modeling tool, and let's add maybe a quick threat in our threat section, right? So again, so this tool it's called Threat Composer. Initially, it was developed by AWS, but the Canadian Digital Services took a fork of this. I like their version more than the AWS version because it lets you draw things out, and which the original threat modeling tool didn't have. So let's just add a quick threat statement. So we have, again, I can't see it properly, but so we have a threat actor, I think, who is unauthenticated, and authorized. I'm sorry, I can't read that. What does it say? Let me zoom in. Okay, and they are able to view trip history, which leads to like stalking, for example, and it impacts our riders, right? So this website gives you a framework or a format to, one, you have your impacted assets, you have the threats you're talking about, you have the prerequisites. So you create this, you have a standardized template for all of your threats, and so you can use this information, like over time, compile them into different like databases. So you can have a list of all your assets, all your threats, all of your prerequisites, and so on. And so we can, and then once we add this threat to our system, let me go back here. Once we add this to our workspace, we can then take a threat, and then we can set the priority for our threat. So we can set this, hey, this is a high threat. And then over time, we can incorporate this into our backlog and give it to our development teams, or we just choose other risk mitigation responses here. And then always we can always discuss mitigations later and controls later. But the important thing is to come up with a list of threats and then make that the starting point for your build process. Because once you know what the threats you're building against, you incorporate security into your build process, so you're not bolting it on later on. Cool. So now we've completed our threat model. Now what, right? So we have a bunch of our threat statements. We do the analysis and the prioritize. Sorry, go ahead. No, it gives you JSON. Yeah. Yeah. So yeah, so once we have all your threats, you can you analyze, you prioritize them, and then you have a bunch of risk response strategies. You have avoid, mitigate, transfer, accept. And the most important thing, in my opinion, is your threat model should be the input to your pen test scope, right? So a lot of you guys, a lot of your companies do pen testing for all of your services, and you don't know where to start. You tell the pen testers, hey, here's our system, here's the boundary in which you're allowed to test, do it, right? that can be very productive, right? They don't know what they're looking at, they don't have the details. And if they're like internal pen testers, they should know what they're testing against. So giving them, so going back to the same tool, right? So you can give them an example is, yeah, you give them all of your threats, you give them all of your mitigations, all of your assumptions, all of your assets, so on, and make this an input to your pentest scope, which makes life easier for you, the designers, and the pentesters. And I'm sure your pentesters will like you more when you give them a better scope. So yeah, going back to the presentation. Okay, so now just to summarize, right? We've done automation of the easy stuff. We've threat modeled reusable components. We threat model the actual features and the flows. We have a risk response strategies, and we have an input to our pen test. So at this point, you've probably done 99% of what you could do, and you're able to do this at scale, and you're able to derive insights that you previously couldn't because of machine-readable formats and having like a bird's eye view of all of your threats, assets, and mitigations. So yeah, that's my presentation. And if you only take two things away from this talk, it is threat modeling can be done at scale, and threat model both features as well as components. Those are if you just take two things away, those are the two things I would recommend you taking away from this talk. Cool. Thank you very much. Do you guys have any questions? Yep, go ahead. It's called Threat Composer. But the one I'm using is if you just Google Threat Composer, Canadian Digital Services, or CDS, that's the first thing that pops up. Yeah. Cool. Any other questions? Yeah, go ahead. Yeah, this one supports Stride natively. Again, I do not like Stride because it boxes you, and Stride helps you. It might give you like things to think about, but this one specifically supports Stride. But I think that they have plans to add other ones as well. But again, this is open sourced. You can always add it, and even in the data flow diagrams, you could customize this for your Yeah, you can customize, like, for example, if your company uses a specific type of authentication, right? You can and so for all of your data flows, you can set what kind of authentication that you guys are using. Yeah, so you can set your authentication, you can set all the custom stuff. So everything is open source here, so you can build it for your company and customize it for yourself. Yeah, go ahead. Without going into too much detail, like it depends on the size and complexity of the service. Small ones take a few hours, really large, really complex ones take a few days. But again, like these few days, you do everything, right? You take the design documents, you like do the entire threat modeling, you create you have the scope for the pen test ready. So it adds a little time to your development process, but you don't have to bolt security later on to your product. Cool. Any other questions? Yeah. Oh, this is open source. You can just go to the GitHub and run it on your own laptop. Yeah. It's also hosted for free if you want to like play around with it. But again, it's open source. You can download it and run it. Yeah.
Even before looking at the conceptual design, have you ever participated in requirements gathering process where those are defined?
Yeah, we actually do, right? Because during the requirement process, we inherit our previous threats. Because once you do a threat model, you can see what threats affected you before, and that drives the requirement process. And that should, like in the SDLC, remember the cycle. All the threats from the previous threat models can help you design around the threats, knowing what you already will be affected by. Cool. Thank you so much, everyone.